Welcome, guys. In this lecture, we shall discuss group 3 elements. Group 3 elements are so called because they have 3 valence electrons. So, of course, you know the number of valence electrons an atom has or an element has determines the group to which it belongs, with an exception of helium, right? Now, group 3 elements you find in this group have 3 valence electrons, and as a result, we put them in group 3. Now, if we don't want to call them the group 3 elements, what other name can we give to them? We can call them the boron family. And why are they called the boron family? They're called boron family because boron is the first member of the group. In group 3, you have boron, symbol B, aluminium, symbolized as Al, right? We have gallium, Ga, indium, In, and thallium. So we have boron, aluminium, gallium, indium, and thallium, Cl, right? And every one of them have 3 valence electrons, right? Now, of course, the fact that they have 3 valence electrons tells us about their chemistry. We expect a different chemistry compared to group 2 and group 1. So what are their chemical properties? But before we talk about the chemical properties, let's make mention of their physical properties. Compared to group 2 and 1, group 3 elements are more of a solid, means that they are stronger solids than group 2 and group 1, right? Group 1 are very soft solids, group 2 are relatively harder solids, while group 3, of course, we are familiar with aluminium. You know how tough aluminium is. Group 3 elements are real solids, right? This group comprises of metals at the lower regions and metalloids at the mid-upper members. So for group 3, indium and thallium are pure metals, while boron, aluminium, and gallium are slightly metallic and slightly non-metallic. Although sometimes we call aluminium pure metals, right? But if we have to look at special features like paramagnetism and diamagnetism, we can say aluminium to some extent is a metalloid. All right. Now, another thing we need to say is if from groups 1, 2, and 3 of the periodic table are collectively called metals. And they are so called because they have no non-metal in them. That means there is no member of groups 1, 2, and 3 that is a non-metal. They are either exclusively metals or semi-metals, but non-metals are completely absent. Hence, we call groups 1, 2, and 3 metals. So you can say group 1 metals, group 2 metals, and group 3 metals, right? Because they all ionize by loss of electrons. So now, let's go to their chemical properties. What are the chemical properties we find in group 3? Group 3 elements, please notice that for group 3, we didn't mention anything like alkali, right? We didn't say alkali whatever, because they do not produce alkali. Although they react with water, right, to give us a compound which we'll look at and give off hydrogen gas. But that compound produced is not necessarily an alkali. Instead, it is in part an acid and in part a base. Now, let's take it so you would understand. Chemical properties of group 3. Chemical properties of the boron family, or you say of group 3, right? What are the chemical properties? Number 1, they react with water, but what kind of water? Water in its gaseous form. Now, remember we said for group 1, group 1 element react with cold water because they are highly reactive. Group 2 react with slightly warm water because they are less reactive than group 1. Group 3 elements are less reactive than group 2 and group 1. So what form of water do they react with? With steam, right? So they react with water, but water in its gaseous form, which is steam. They react with steam. Sorry. They react with steam to produce an amphoteric oxide, not an alkali now. an amphoteric oxide, which is an oxide, partly an acid and partly a base. An amphoteric oxide and liberate hydrogen gas. Now you can give a couple of reactions which lead to the production of hydrogen gas. If you ask to describe the laboratory preparation of hydrogen, you know what to say. Is that you say reaction of group 1 metals with cold water, or you say reaction of group 2 with warm water, or even reaction of group 3 metals with steam. All give you hydrogen as a byproduct. So the liberates hydrogen gas. Hydrogen. Or you say gaseous hydrogen. So let's see. If aluminium reacts with steam, and how do we signify this as steam? We put it in its gaseous state. Now, reaction of aluminium with steam gives us an oxide of aluminium and gives us hydrogen gas. Okay, if we are to go by the law of conservation of mass, how do we balance this? This is 2, right? That is 3. So this is 3, and this is 3. So it is balanced now. And what is aluminium oxide? It's an amphoteric oxide. Amphoteric oxides are oxides which can act as an acid as well as a base. Now, there is a member in group 2 whose oxide is also amphoteric. So it is more of amphoteric than base. And what is the oxide? It is the first member, okay, which is beryllium. Beryllium oxide is more amphoteric than basic. And the same thing with aluminium, just that beryllium is a group 2 element, right? And that's it. So where we have an amphoteric oxide, and that's what you produce when group 3 members react with steam.